The Andromeda galaxy played a pivotal role in reshaping our understanding of the universe and our place within it. Our galaxy, for example, is the Milky Way galaxy, and the nearest galaxy to us is the Andromeda galaxy. We think there are about 100 billion galaxies in the visible universe. It served as compelling evidence that the cosmos and the concept of creation don't revolve around Earth. This discovery shattered the notion that the Milky Way was the sole galaxy in existence, suggesting that we are just a tiny part of the vast universe. While we have accumulated knowledge about Andromeda over the last century, much of it was gathered from observations made. However, with advanced tools like the James Webb Space Telescope now at our disposal, our perspective has drastically changed. Surprisingly, the recent data obtained from the James Webb Telescope has upended our previous notions about the Andromeda galaxy. Another cosmic puzzle needs to be solved. But just as we receive signals from our neighboring galaxy, leaving the entire scientific community astonished, join us as we explore how the JWST received an alarming signal from our neighbor, the Andromeda galaxy. Indeed, the perception of the Milky Way has undergone significant changes over the course of human history, shaped by our evolving understanding of the cosmos. In the past, when our technological capabilities were limited, the Milky Way appeared as a hazy band of light across the night sky, inspiring various interpretations and mythologies. It was often seen as a mystical and central element in the cosmological beliefs of different cultures. As our science knowledge advanced, particularly with the development of telescopes and the work of astronomers like Galileo Galilei, we began to realize that the Milky Way was not just a celestial concept, but a vast collection of stars, planets, and other celestial objects. This realization revolutionized our understanding of our place in the universe. Today, thanks to modern telescopes and astronomical research, we have a much clearer picture of the Milky Way as a barred spiral galaxy containing billions of stars, including our own Sun. In the 1920s, Edwin Hubble, an American astronomer, made a transformative discovery using the 100-inch Hooker telescope at Mount Wilson Observatory. Hubble observed distant nebulae beyond the Milky Way. Through the observations and analysis of these objects, he showed that they weren't actually part of the Milky Way, but were entirely separate galaxies, each containing billions of stars. One of the closest of these galaxies was the Andromeda galaxy, also known as M31. The Andromeda galaxy has a rich history of observations that dates back centuries. One of the earliest known records of this celestial object can be traced back to the 10th century, when the Persian astronomer Abdul al-Rahman al-Sufi described it as a small cloud in star charts from that period. The significance of these observations lies in the fact that al-Sufi was able to identify this distant cosmic entity without the help of telescopic instruments, relying solely on his keen eyesight and observations. It wasn't until 1612 that a more detailed description of the Andromeda galaxy, based on telescopic observations, was provided by Simon Marius. His work laid the foundation for future astronomers to study this massive cosmic structure. Later, in 1764, the renowned French astronomer Charles Messier catalogued the Andromeda galaxy as M31 in his well-known Messier catalogue, mistakenly attributing its discovery to Simon Marius. However, that doesn't diminish Messier's role in putting Andromeda on the map. For almost 100 years after these observations, astronomers worldwide sought to understand more about this mysterious galaxy, each adding to the last one's findings. Before that, Galileo Galilei, an Italian astronomer, revolutionized our understanding of the Milky Way in the early 17th century. Using his newly developed telescope, he made groundbreaking observations that challenged the prevailing Aristotelian cosmology. In 1750, English astronomer Thomas Wright proposed a new hypothesis in his work, an original theory or new hypothesis of the universe. According to Wright's speculation, the Milky Way was not a random distribution of stars in space, but a completely flat layer of stars. He also suggested that a portion of this vast structure was our own solar system. While Wright's hypothesis was a step forward in understanding the structure of the Milky Way, it was still limited by the observational technology available at that time. A significant leap in understanding the nature of the Andromeda galaxy occurred in 1864, when the English astronomer William Huggins made a groundbreaking observation. He studied the spectrum of Andromeda and noticed that it was different from that of a typical gaseous nebula. This observation paved the way for the world to understand Andromeda for what it really is. The Andromeda galaxy has a mass estimated to be between 1 and 2 trillion times that of our Sun, making it a colossal cosmic structure that just happens to live relatively close to us in the vastness of space. In all the research conducted until now, scientists believe that Andromeda is about 10 billion years old, making it quite ancient in cosmic terms. One intriguing aspect of Andromeda's origin is the hypothesis that it came into being through the merging of several smaller protogalaxies. This suggests that over billions of years, smaller galactic entities gradually came together under the force of gravity to form the majestic Andromeda galaxy we see today. Galactic mergers are common occurrences in the cosmos, shaping the growth and structure of galaxies. However, for a long time, astronomers thought Andromeda was significantly more massive than our Milky Way galaxy. This misconception is understandable, considering the limitations of the observational tools available in the 1700s and 1800s. Recent research has brought about a reevaluation of these beliefs. New findings have led scientists to somewhat reduce their estimate of Andromeda's mass, while simultaneously increasing the mass attributed to our Milky Way. The current understanding is that the masses of these two cosmic giants are much closer than previously thought. So, if you were to be on Andromeda and looked at Earth, you'd see just as massive of a galaxy. This puts into perspective how colossal the Milky Way itself is to the Andromeda galaxy. Physical dimensions, though, are what astronomers totally agree on. It's known to stretch farther than our own Milky Way. With an impressive diameter of about 220,000 light-years, Andromeda surpasses the Milky Way's estimated diameter of roughly 100,000 to 175,000 light-years, making it a truly significant cosmic entity taking over a large region in space. This revised perspective also highlights the complexities and challenges of accurately measuring the mass of galaxies. In the heart of the Andromeda galaxy, the supermassive black hole exerts an immensely powerful gravitational pull on surrounding stars. As these stars orbit around the black hole, they follow elliptical paths similar to planets orbiting the Sun in our solar system. At a certain point in their elliptical orbits, stars come closest to the black hole, and this point is called the periapsis. At the periapsis, the gravitational forces are at the strongest they can ever be, causing the stars to move at their highest speeds. This is when the stars bunch up and become more concentrated in space around the black hole. As they bunch up, the stars release energy in the form of radiation, including visible light and other types of electromagnetic radiation.